ओके कूलिंग. सो आज के चैप्टर में हम लोग देखने वाले कूलिंग कॉस्ट पावर कॉस्ट. ओके कूलिंग. So what is the cooling here? Means cooling is an extremely important process in a modern data center. Cooling system of server rooms ensure appropriate operation condition of IT system, such as servers and data storage. But on the other side, they consume a lot energy. So cooling is a modern system in data center. So with the help of this means cooling system of servers room sure appropriate operation condition of IT system. So here we can say that cooling is taking the lots of energy, right? So such as servers and data storage, but on the other side consume a lot energy. So some estimate that cooling can account the upward of 65% of IT department power usage. That obviously a big amount and not something that should be overlooked. If you need more cooling power rather than simply turning up the air condition, it's useful to figure out how much you are actually spending and how much you are actually need to spend. Okay, so use of for free cooling. Chillers typically use the most energy in data center. Cooling is infrastructure, so there is a largest opportunity to for saving by minimizing their use. So if you minimizing the cooling, then you can if you minimize cooling, then you can save the energy, power energy, right? Taking advantages of free cooling, remove heat from facility without using chiller. This can include using low temperature air. Then you can say a large thermal while tree or more than one way free cool water and air economics are true and really readily available. So advantages of cooling here. Power means evaporation is a power tool in our bodies. It helps us maintain our temperature even when outside temperature are warm. Then we are. It also works similarly in data center. Cooling tower as hot water from the data center flow down to the towers through a material that speed evaporation. Some of the water turns to vapor. A fan lifts this vapor, removing the excess heat in the process, and tower sends the cool water back into the data center. So use the internal cooling power seawater. Water seawater isn't the only way to free cool. Some data center uses seawater to cool without chillers. Means some seawater means how we can say the seawater without chillers. They are using seawater to cool without chillers. Data centers can be stabilized in place like Hemina, Finland, because it is a cold climate and its location on the cold means on the globe of Finland as a Google does. The cooling system are the design which pumps cold water from the sea of the facility, transfer heat from the operation to see the water through a heat exchanger, and then cool this water before returning it to sea. The approach can provide all of needed cooling year round and does not need to install any mechanical chiller at all. So here if you try to decrease cooling chiller to use, then you can save the power energy, and with the help of this we can save from means radiation, carbon dioxide. It will be emitted less. Then we can so that it will be not impact badly impact on our environment, right? So here here optimizing power distribution. Okay, so we can minimize power distribution, right, losses by limiting as many power conversion steps as possible. For the conversion steps, make sure to have a specified efficient equipment, transfer and power distribution units. One of the largest loss in data center power distribution is from a from the uni power supply UPS. So important to select high efficiency model. Also keep high voltage as close to the power supply as supply possible to the reduce line losses. Building custom highly efficient server. Usually server are high performance computer that runs all the time. Means building custom means here in this building custom high efficiency server. Okay, build custom high efficiency server. So usually server are high performance computer that run all the time. They are core of data center and should be designed to use as little energy as possible. It can be done by minimizing power loss and by removing unnecessary parts. Okay. Also sure that server use a little energy when they are waiting for a task rather than hogging power when there is a less computing work to be done. So optimizing power part. Okay, optimizing the power part here. A typically server waste up to third of the energy it uses before any that energy reaches the part that do not actual computing server loss. Standard quit is set low DC voltage. They then lose means see here optimizing part in this. A typical server wastes up to a third energy it uses before any of the energy reaches the parts that do the actual computing server losses the most energy at the power supply which convert the AC voltage means most energy which power supplies convert in AC voltage you can say then coming from the you can say the standard outlet to see set of low DC voltage they then they lost more at the voltage regulator which further converts the power supply's output to the voltage required by microchips designed with low efficiency standard in order to save on initial cost. Traditional servers end up costing much more in electricity in the long run. To use efficient power supplies and highly efficient voltage regulator modules to ensure that most of the power goes to the component that do the actual computing work. Okay, the cut out the two AC/DC conversion step by putting backup batteries directly on the server rack. It estimates an annual saving of the 500 kilowatts per server over a typical system. So try to minimize the cooling and try to uh, means use another way. With the help of this, we can cool also. We can use our power in proper way, and we can save also. Then we can save our environment cooling computing, right? So here, power cost is let's take the moment to understand how much power cost and how those costs are computed. Electricity is a paid for a kilowatt hour. This is a measure of the hardly consumption of electrical power. For the sake of easy math, let's use basic electrical device, the household, then light bulb to determine how much electricity costs. A 100 watt bulbs 100 watt hours electricity in 60 minutes Okay, as such a 10 100 watt light bulb will use the total 1 kilowatt electricity per hour. But electrical power costs are different around the country. So here's New England commercial power cost in 14.17. Here new some reason that is east north west north center south alternative east south west south like this is countries that their use in 2016 40 38 6 7 like this power are uses and commercial power cost in 2006 14 12 means 1 or 2% differences are there in all areas country. So most of companies area just running on the light bulb. Let us put the number in the elastic term. Industrial data crop estimate that companies worldwide spend about $29 billion to cool data center in 2007. Causes for cost. Power cooling is a major component of your power consumption, right? And you can say cooling is a major component of your power consumption. You know very well, because of if we on the AC, then power it consumes the more power, right? So extension your IT budget. Okay, so here causes of, right, we can say that is a major component, major component of your power consumption. Okay, and extension your consumption and extension, your IT budget, a number of issue drive up. Okay, a number of issues drive up power consumption and cooling cost, including the following: increased power consumption as more server and storage devices are deployed. Increased power consumption. So, a number of issues drive up power consumption and cooling cost. A number of issue. So let's discuss these issues, right? Okay, number of issues. First of all, a number of issues drive up the power consumption and cooling cost, including following issue. First one is increase the power consumption as more increase power consume as more server and storage device are deployed. As more server and storage device devices are deployed. Okay, so what is the first is the increasing power consumption as more server and storage devices are deployed. Means try to use whenever we require, right, whenever we need it, then try that time only try to use this consumption, means this some storage device, right? Then increase heat density in the rack, means cause the cost, I mean it causes for cost of power, means if we using the more power, then what types of problem we can problem like occur, like increase the heat density in the racks because increase computing power in the confirmed space. So because of this increase the, like this type of issues are occurring, increase the heat, right, density. Why it is increased? Because in a rack, because of increasing computing power in a conformed space. Then irregular heat load in the data center. Then irregular irregular heat load, heat load in data center, in data center. So here, irregular heat load in data center. This is by poor planning for heat management as the topology of the data center changes. Increase power cost across the USA. Then increase the power cost. Increase the power cost across the USA. A tendency of overcooled data center, the floor cooling impulse leads data center managers to overcool their data center by more 2.5 times what is needed. So this is are the some issue which badly impact our environment. So calculating cooling needs here, calculating calculating cooling heats. So in this section, we will talk about how you can figure out much cooling your system will require. Okay, so all the equipment in your server room generates heat. So जितना भी इक्विपमेंट है जो कूलिंग से पर्पस के लिए वी आर यूजिंग या अपन यूज करू ते ऑफ कोर्स बट ऑब्वियसली इट विल बी जनरेट द हीट राइट so does the light and so do the people working there. All these sources of heat contributed to the heat load of the server rooms. Typically, this number is expressed in British thermal units. So this expression is or kW. Okay. So this expression is expressed in British. Is it right? But here, why is showing like this? Okay, need to write like capital. That's British thermal units. That is called BT, British thermal BT units. Okay, British thermal units, or we can say kilowatts, or you can say that is kilowatts. 1 kilowatt is the same as a means kilowatt here British thermal unit, we can say anything. 1 kilowatt is same as a 3412 BTU BTU. Yes. मतलब 1 kilo if you using spending 1 kilowatt that is same as a British thermal unit is nothing but it is kilowatts. If you using 1 kilowatt that is nothing but BTUS 3412 BTUS. Okay, so in calculating the cooling heat here, all the equipment in your server room generates heat. So does not lighting and so do the people working there. All this source of heat contributing to the heat load of the server room. Typically, this number is expressed in British thermal unit. See here, this is right or kilowatts. 1 kilowatt is the same as a 3412 BTUs. So your server room equipment vendors should be able to tell you how much heat load each pieces of equipment generates. So your thermal room means your vendors, if your server room equipments vendor have to save able to save you one equipment के लिए कितना amount का BTUs लगने वाला है. Okay, that is kilowatts. So for your air conditioner to cool the a room, okay, air conditioner to cool room, its output must be greater than the heat load. Before buying any new cooling equipment, it's important to figure out how much you need. Okay, so means air conditioner to cool room, its output must be greater than the heat load, right? So before buying any new cooling equipment, it's important to figure out how much you need. Suppose to determine the heat load, you must take into consideration several factors, not just the heat load of your equipment. The following section address this additional consideration, like room size. The room size itself requires cooling. To calculate the cooling needs of the room uses formula. So suppose room size में how to we require the cooling, मतलब what कितना amount का आपको cooling you require. So suppose room size, okay. So suppose the formula is there, like room area, suppose, okay. So room area, okay. Room area BTU, it's nothing but you know very well, kilowatts, okay. BTU, then equal to length, that is the meters, m, then into width in meter, then into 337. So this is your formula, means अगर room area कितना है कितने size का, how much you require the cooling, means determine the heat load, you must take into consideration several factors, not just the heat load of your equipment, okay. To section address this additional consideration, the room itself require cooling. To calculate the cooling needs of the room, मतलब how much you require require cooling needs for your room. So this is a calculation formula. With the help of this we can figure out how much we require the how much we need for our area, right? So window, most of us server rooms have no window, okay. If your has none, you can skip this calculation. So suppose most of the room has no windows. If you don't have windows, then okay, wait, if you don't have windows, then you can skip this calculation. If you do have window, look at this formula to determine which is most applicable to your data center. So south side window, okay. I'm typing like SW, okay, means south window, okay. Consider like this. South window W BTU, okay. South window BTU, that is south facing window length. South facing window length, okay. South facing window length, meter into V, meter into 870, okay. Then north window BTU. So here north facing window length in meter into width into 165. If there are no builds on window, multiply the result by 1.5. If you are in the south hemisphere, swap this formula in the north hemisphere, the heat on south facing window is generated. In the southern hemisphere, the heat on the north facing window is generated. Add together result, calculate to get your final amount. Window BTU, like at both windows BTU equal to south windows south windows BTU plus north windows, just a minute, north windows North window BTU. Okay, north window north window BTU. Okay, so here we can say that, see here, the room area. So window, if we don't have the windows now, north and south, like, so no need to calculate the, no need to include your window size here, but so directly you can calculate room area. That is, it's nothing but the kilowatts. So length meter into width meter, if you have to, into with 337, means you can say to cooling vendors that much power you have to spend in your room. So that means utna type ka voltage ka they can give to you. Then in windows, if you having windows, then you have to calculate like this: south windows, and like south facing window, length into windows, width meters into 870, and north, the north facing windows length into 165. So windows between south windows, then after you have to addition this both. Okay, so people in the room, you probably don't have someone permanently in the server room. If people aren't in there, you can skip this section. However, if you do have people located in the server room, the heat load goes up to 400 BTU per person. Here's formula: total occupied BTU equal to number of occupied into 400. Equipment. Obviously, most of the heat generated is from your equipment. You can find the equipment's power consumption in this uh, documentation or over the. Okay, equipment. Obviously, most of the heat generated is from your equipment. You can find the equipment power consumption in its documentation or on vendor's website. If it's not written on a sticker with the serial number, don't forget take into consideration any other equipment that might be in the room. Maybe there is a photocopier, additional equipment, right? Equipment BTU is total weights, all the equipment. So lighting, multiply the total watts for lighting by 4.25 as shown in the following formula. Total cooling requirement. Now just add up all these numbers and you shall get total amount of cooling you shall need to your data center as follow. So the total heat load room area BTU plus windows BTU, total occupant BTU plus equipment BTU plus lighting. You can take this number with you when you go air conditioner shopping. Smaller area conditioning units have a cooling capacity of between 5,000 and 10,000 BTUs. Larger units use measurement in the tons of cooling. 1 ton of cooling and about the same 12,000 BTUs. So this is all about how much cooling you require, and with the with the help of this calculation, you can tell to the vendors server, means cooling vendors, how much you require. Then in turn, it will take more amount money, means more amount of calculation, right? So this is all about the cooling sectors, cooling, calculating cooling heats. Okay, so today's lecture over here. Thank you.